Certain techniques are used for trigonometric substitutions when we're doing integration. Best way, once again, is to do it by example and show you how to do one. The integral of 1 over a squared plus x squared dx. Now the substitution here is different to what we've been doing before. We let x, not u, let x, this x down here, equal a tan u. That is a substitution we use when we've got 1 over a squared plus x squared. X equals a tan u. So then we can find dx du. A is a constant. Root of tan is sec squared. And because we're going to do a substitution, excuse me, we're going to have to substitute for dx, so we need to make dx the subject here. So just multiply both sides by du and we get dx equals a sec squared u du. Okay, so now we can do, write out the question again, 1 over a squared plus x squared dx is equal to the integral of 1 over a squared. Now instead of x squared, we can write the square of that, so that'll be plus a tan u squared. So we've substituted for x squared there. And dx is equal to a sec squared u du. When we square that, we get a squared tan squared u, and so we get a squared plus a squared tan squared u. So a squared is a constant to both terms. So we can take a squared out the front. A squared times 1 will be a squared plus, now this is a squared tan squared u, so that'll be just tan squared times a sec squared. This a, we cancel a squared, so we've got 1 on a, and 1 on a is a constant, so it'll come out the front. 1 on a times the integral of sec squared u over 1 plus tan squared. By your identities, 1 plus tan squared is equal to sec squared, so this is all replaced by sec squared u du. Okay, so sec squared is moved across to there just by multiplying 1 times sec squared, and 1 plus tan squared is sec squared down there. So we've got 1 on a, sec squared u over sec squared u is just 1, integral of 1 to u. The integral of 1 with respect to u is just equal to u plus the constant of integration. Now, if x, by our substitution up here, x is equal to a tan u, we divide both sides by a, we get x on a equals tan of u. So u is the angle whose tan is x on a. Another way to write angle whose tan is arctan. So now we can do the substitution for u there. U is arctan x on a, so it'll be 1 on a instead of u. We'll get arctan x on a plus our constant of integration. So trigonometric substitutions. They are slightly different substitutions of what we've been using before. Instead of letting u equals, we let x equals. And when it's 1 over a squared plus x squared, we use x equals, we always use x equals a tan u. From there we get a rule for what dx is, so we can make a substitute there. It's easy to make the substitution for that x. Rewrite the question, do the substitution. Some things will cancel down. We've got to know our trigonometric identities. We know that 1 plus tan squared equals sec squared. Because this is 1 on a, it can come out the front. The integral of 1 is equal to u, so it's 1 on a u plus c. But we've got to find out there was no u in our original question, so we've got to rearrange that to make u the subject. We did down there, and u is equal to arctan. The other one that you should be able to do this way is the integral of 1 over square root of a squared minus x squared dx, and you let x equals a sine u, and it is a similar type of process of what we've done above there, and you should get that as equal to arc sine x on a plus c. Okay, so they are the two you need to be able to do. The integral of 1 over a squared plus x squared dx is equal to 1 on a arctan x on a plus c, and the integral of 1 over square root of a squared minus x squared dx is arc sine x on a plus c. Both of them using trigonometric substitution.